Missed a few topic B, A, C, and E questions in the middle, so I'm just gonna go through that, and these are some extra questions. So question 16. Two wires X and Y are made of the same material and have equal length. Diameter of X is twice that of Y. What is the ratio of resistance of X to Y? Let's bring out our data booklet, and we have our formula, right? Our resistivity is equal to our resistance divided times A, which is our area, divided by L. And we're told equal length, and we're talking about resistance. So let's make R the subject, resistivity times L divided by area. And so what we can say is it's proportional to 1 over area. Because same material, same length, that means L and P are constant. Okay, and so what is our area? 1 over, it's a wire, so we say pi r squared, right? And so we can just say proportional to r squared. So the diameter of X is twice that of Y. So doing X over Y. So let's do R X over R Y is equal to 1 over diameter of X is twice that of Y. Okay, so 2R squared, 1 over R, right? We're like, R is the radius of Y. And we can even just say it's proportional to diameter squared as well. And so, in order to not confuse you guys, 2D. Right, so when you're doing paper 1 questions, just remember this. Do not do R over 2 is equal to, because it works out to be the same. And so what we can do is, and so what we get is 1 over 4D squared. Sorry, this should be squared. And that's over 1 over D squared, which is just 1 over 4. So our answer is A. Hopefully that made sense. And we can move on to this question. 17. Cell has EMF 3 volts, internal resistance of 2 ohms. Cell is connected in series with a resistance of 10 ohms. Okay, so we have a resistance of 2. What is the terminal potential difference of the cell? So what we have to do is find, we're talking about the potential difference of the cell. So if we put a voltmeter right here, right? And so let's find the current of the entire circuit, right? First we need to find that. Current is V over R, and that's total resistance. So V is 3, or EMF, let's say. R plus R, and we have that formula anyway. So let's do 12. Right, this is our formula. Let me just rewrite it to make it clear. R. So that's 3 divided by 12, which is 0.25, 1 over 4. And now what we have is we want the voltage of that. So we use the same equation, IR plus IR, and we know this is our voltage. So V right, and that's the voltage across the cell, right? And this is the voltage, across the cell and on the whole circuit, because this is in series, right? And this is our voltage lost in our cell. And so we want to subtract that from our EMF, right? Hope this makes sense. And so what we get is EMF is 3 minus 0.25 times our resistance, internal resistance, that is 2. And so we get 0.5 here, so that is 2.5 volts. So our answer is C. That's our answer. Let's see, any more B's? Yes, we do. Check these out. These are not in our new syllabus, so just cancel those. 24. Fuel has mass density. Okay, so it's important to understand what these mean. Kilogram per meter cubed, right? When we're talking about density, we're talking about something over a volume. And then we have energy density, that is joules per meter cubed. And what mass of the fuel has to be burned to release thermal energy, E? We're going to find the mass. Okay, so just looking at these, we can try and figure it out. So energy is in joules, right, is equal to our, we have mass here, right? So we have a mass. We want our joules to be on at the top, so we have U up here. Now we have meters cubed, so we need our mass density down here, and we need our energy down here. Is we need our mass divided by our mass, right? And let's just look at how the units cancel out. We have joules per meter cubed, or let me write that as, and we have density, kg cubed, and we have our mass is kg. Oh, sorry, yep. Our mass should be up here, and so we have kg up here. And so everything cancels out nice and cleanly. And so this is just how you can do it if you have no clue what the formula is, because it's not given in our data booklet. And so we have joules, right? That's what we end up with. And so now just reorganize and make M the subject. M is equal to energy times our mass density divided by our energy density. Right, and that gives us A as our answer. And that should be right. And now on to question 25. We have a simple model of the energy balance in Earth surface atmosphere system. The intensities of the radiations are given. What is the average intensity radiated by the atmosphere towards the surface? So what we have is energy balance diagram, and we're trying to find this, right? What's specifically radiated by the surface. So we have this incoming ray that goes straight through the atmosphere and is absorbed by the surface. Some of it is reflected. And so what we see in these energy balance diagrams is whatever goes out of a surface layer, of a layer, goes in as well, right? So we have 240 coming in. So we have 240. We have 390 going out, minus 390. And we have something coming in, and we need to find out what that is. And we want everything to end up being 0. So whatever comes out whatever comes in goes back out. So 240 plus, this is our x, plus x is equal to 390, and so x is equal to 150. So that's our answer. B, another, and you can sort of see how this works with everything. We have 100 going out of the atmosphere and 240 going out. So we have 340, and we have 340 incoming. And so that balances, the atmosphere layer balances. And now what let's look at the total coming into the atmosphere. That includes 390, right? That includes the 340. So that's 340 plus 390 is equal to 730. Yeah, should be. And then we have 240 going out, 150 going out. So 240 plus 150 plus 240 going out again. And we have 100 going out plus 100. And so what we have here is 480, 580, 580 plus 150, and that gives us the exact same 730, right? So that's how you can find these answers even if you are a bit confused. It's an energy balance diagram. So read from the title, I guess. And so I think that's it for topic B. Yeah, that should be it. Thank you guys. Hope you learned something or this was beneficial in some way. If it was, please drop a like and subscribe. It really helps. See you later.